On this channel, we provide useful programming information with practical code examples. This time, the topic is best practices in TypeScript programming. This guide explains practical best practices for leveraging TypeScript's types to reduce bugs and write more readable code. Enabling subtitles will make the code descriptions easier to understand. The greatest benefit of TypeScript is preventing bugs with types and making code intent clear. Best practices are not merely rules but a set of principles to write safe, readable, and maintainable code. Below, we introduce commonly used TypeScript best practices with practical examples. First, let's look at the point of avoiding any and giving meaningful types. Any completely disables type checking, which defeats the purpose of using TypeScript. Instead of using any just to make things work, it's important to provide types that are as descriptive as possible. This code can accept any value, so runtime errors cannot be prevented. By defining types, you clarify the intent of inputs and outputs and improve safety. Next, let's look at the point of always explicitly defining object structures using type or interface. If you use objects ad hoc, their structure can become ambiguous. Always extract types for reusability and maintainability. Even in small pieces of code, it is important to develop the habit of separating types. By naming types, understanding the overall codebase becomes much easier. If you use raw, string, or number types for conditionals, unexpected values can slip through. By using union types, you can represent only the allowed states at the type level. In this code, meaningless strings or incorrect values cannot be detected at compile time. By using union types, you can reliably eliminate impossible states at compile time. As a result, the safety of conditional branches and the reliability of the code will improve. Next, let's look at the point of explicitly handling null and undefined. In TypeScript, it's important to express the possible absence of a value in the type. If you keep things ambiguous, they may lead to runtime errors. Email may not exist, so you should handle it with that assumption. Always check optional values before using them. Next, let's look at the point of not overusing type assertions. Type assertions temporarily bypass TypeScript's type checking to declare, I know this value is of this type. Overusing them undermines type safety. In this code, even if the actual value is not a string, no error occurs, which can cause runtime errors. As shown in the following code, choose to safely check using type guards first. Type guards are a mechanism to safely determine a type while checking the actual value. By prioritizing type guards over type assertions, you can more easily prevent runtime errors. Next, let's look at the point of not relying too much on inference for return types. TypeScript's type inference is powerful, but it's safer to explicitly annotate return types of public functions. This minimizes the potential impact of future changes. Clearly state your intent even in small functions. Writing out return types increases the stability of your API. Next, let's look at the point of safely accepting external input using unknown. For external input such as APIs, JSON, or user input, use unknown instead of any. By doing so, you ensure that all values are validated, maintaining type safety. Here's how to validate types with unknown. Unknown cannot be used as is. It is a type that requires validation. It is especially effective when handling external input. Next, let's look at the point of increasing expressiveness by combining small types. Defining large types all at once reduces readability and maintainability. Divide your types into meaningful units and combine them as needed. Treating types as components helps organize your design. Type and interface can both define types, but their intended uses and characteristics differ. By using them for the appropriate roles, the intent of your type definitions becomes clearer. If you duplicate common parts like this, your code becomes fragile to changes. Interface is ideal for designs that involve extension, extends, and is best suited for expressing the shape of objects. On the other hand, type is more expressive and suitable for handling union and intersection types. Type is well suited for expressing states, options, and combinations. As a rule of thumb, use interface for object structures and contracts, and type for when you need the expressiveness of union, intersection, or type operations. Both work similarly, but it's important to choose based on what communicates the reason for the type's existence. Finally, let's look at the point of writing types as documentation. Good type definitions convey more information than comments ever could. It is important to aim for a state where the specification can be understood just by looking at the types. In this way, one of TypeScript's major strengths is that type definitions can function as a kind of specification document. TypeScript best practices are not about being overly strict. The essence is to clarify intent through types and write code that is robust to change. By accumulating small rules in daily development, you can achieve long-term effects such as easier reviews, fewer bugs, and better understanding for your future self and others. First, by thinking, how can I express this with types? You will write high-quality, TypeScript-style code. The source code for this video can be downloaded from the official website. If you like, please visit the URL in the description to aid your learning. Thank you for watching until the end. If you enjoyed the content of this channel, please consider subscribing.